Hi friends, how are you? So myself Shreya Bamihar, welcome back to my channel. So today I'm going to discuss with you people that is XRD pattern, how to calculate the XRD patterns of copper, of NaCl and gold. I will tell the entire explanation of gold. In the same way you can try for a copper as well as sodium chloride. Okay, so before going to that calculation and all, I would like to explain some things about powder method. So here powder method nothing but this method was introduced by DB and Scarer, okay, in 1916. So here what they are doing means they are taking a finely powdered crystalline substance or a material. They crush it very finely and they are filling it in the capillary tube. Here we required a one capillary tube, as you can see in the diagram. So this is the capillary tube. This is the capillary tube. So inside this capillary tube we have a finely powdered substance or a material. So here what happens when we this capillary tube is kept inside the debase carrier camera so that we can observe the pattern very clearly with the help of that camera. That camera is called as a debase carrier camera. Okay, at the one end we make we have a one hole, and from that we are passing a X-rays, that is a monochromatic X-ray of as we know that X-ray have the less wavelength. Okay, and these are a continuous one. Okay, and these are produced when there is a production of a gamma rays or a gamma, when these are produced in a gamma decay, as we studied in nuclear physics. Okay, so here what we are doing, when this X-ray pass through this uh, camera, what happen, it falls on the capillary tube. So in the capillary tube we have the finely powder. So when it falls on that finely powder, some part of the rays get reflects back, some part of the ray get reflects back, some part of the ray transmits, some part of the ray refract. Okay, this phenomenon takes place inside this entire experiment. Okay, so during this we get some patterns inside this camera. So what are those patterns, how they looks? The pattern looks like this. So in the 0 degree they are slightly curvy, and when they move towards the 90 degree they are slightly that make as a straight line. When they are moving towards a 180 degree, then again they take a backward curvy. Okay, backward curve. So this is the pattern. For this pattern what we are doing, we are finding the this XRD entire calculation and all. Here what we are doing, we are taking example of gold. Okay, AU nothing but a gold. So how to calculate this, how to calculate this? We have a pattern like this is our pattern. This we get from the XRD, that entire experiment which is carried out before by the scientists and all. So we just taking this pattern and we are just calculating all the things. Okay, so here what we are calculating is nothing but we are calculating the lattice parameter. Okay, lattice parameter, that is A. So to get the A value we need a sine square theta by S. So we get a value of sine square theta by S. How to get this sine square theta by S? That we have to do this tabulation. Okay. So here we are considering a reference point as 10. Reference point. How to take this reference point as 10? Here what we are doing. If you keenly observe this pattern, I know this pattern is not so clear. So here the value is 30, 40, 50. Okay, so like this the values are arranged. Okay, the difference between these two pattern, that comes as 10. Okay, the difference between these two pattern is 10. That is our reference point. Okay, this is clear now. Okay, so then, so you can, hmm, 10. Then length is equals to 5 point. How to take this? This can be taken from the word normal scale. Okay, so what we have to do, we have to just measure this length. We have to just measure this length. So this is about this is 5 point, hmm, this is 5.2. So this L value is 5.2. When you we have to measure this length. Okay, that is 5.2. So we have the scalar factor, that is S is equals to R by L. This is the formula for a scalar factor. You have to remember this. S is equals to R by L. R nothing but reference point, L nothing but length. We have to just substitute that, then we get a answer. This answer is nothing but scalar factor S. So from the this formula we got yes. Now we have to sin square theta and we have to find a lambda. Okay, so lambda, as we know, it is a constant value that will be given for you people. Okay, so now we have to take x values. So how to take this x values? So these x values are taken from this. If you observe cleanly from 0 to this, uh, the uh, the measurement is, if you keenly observe this, the measurement is 4.4. Okay, so from here to this point, wherever we got a peak value, no, that much only we have to calculate, not that not this small peak one, wherever where they have written this AU is equals to the Miller indices HKL value, no, that only you have to take. And from 0 to this point, I think it is 7.1. If you keenly observe this is 7.1. Okay, like this we have to write all the x values corresponding that with that we have a formula as 2 theta is equals to r plus s in s dash into x. Okay, so as we know, we have already found x dash value, and for r, so first reference point r position, that is 30, for second 40, for third 50. So whatever here point comes, no, that you have to take. Okay, not just like a randomly, whatever the point here comes to, that you have to take. R is equals to 30. So then what happens, this you have to calculate, and from this we got a theta value, and when you substitute in a sine theta, we get a corresponding, and that squaring is sine square theta. So we have to find the this for a crystal, that is SCC, BCC, FCC. SCC nothing but simple cubic crystal, body center cubic system, face center system. So simple nothing but it contain a 1 unit cell. Okay, in a body center we have a 2 unit cell, in FCC 4 unit cell. So here what happened, the all the lattice points are at the corner. Here BCC, all the lattice point at the corner and one is at center. In FCC, all the lattice points are at corner, as well as they are attached to the walls of that cube. Okay, so all the faces of that cube. So this is all about the FCC, BCC and SCC. Okay, here we have a formula, S is equals to S. Okay, this is a S value, and here we have a sine square theta by S. Yes, a sine square theta by S. Yes, a sine square theta by S. This you have to remember, and this is very easy. You can remember this. So for S value, for a simple cube, we have a 1, 2, 3, 4, 5, 6, 7, 8, like that. For a BCC, they are all even numbers. This is very simple, 2, 4, 6, 8. For FCC, what happened? This we have to remember. These two are very easy, and this you just have to remember. 3, 4, 8, 11, same way it goes on. Okay, so sine square, already we found the sine square theta, that just divide by this numbers. Just divide by these numbers. This is the entire calculation, and here we got so how to find out that how to recognize this is a sine square theta by S value? Here we have a 3, no. So how to find out? How to find out means, if you observe this keenly, not a single value is similar. The all the value, it means the all the values are different one. Here also, here somewhere, no, here these last digit only they are matching, but before the two digits are not matching. If you come here, you can observe that these two are matching. If a column contain at least two matching points, or the values, you can take that and just put it in here, sin square theta by s. So you get some value, just calculate it. So this entire calculation provides you that this gold, the crystal, belongs to FCC. This is the entire experiment. I hope you understood. Thank you for watching. Follow and subscribe. Bye bye.